Imagine you wake up 10 years from now and you see human robots everywhere. Not just in factories, but in warehouses, restaurants, hospitals, and potentially even inside your homes. It sounds like science fiction, but some of the world's most influential technology leaders believe this transition could happen much faster than we think. Elon Musk recently made an astonishing prediction. Within the next 5 years, there could be at least 100 million to potentially even a billion humanoid robots doing physical work around the world. Now, whether Musk's timeline is realistic or not is a different question. But recently, something interesting happened that shows how quickly robotics is progressing. China hosted what is essentially the Olympics for humanoid robots. And more than 2,000 robots from 16 countries competed across 51 events, including sprinting, football, table tennis, boxing, even tasks designed to mimic real world. And some of the results are genuinely crazy. One Chinese humanoid robot ran 100 meters in 9.39 seconds, faster than Usain Bolt world record of 9.58 seconds. Of course, there's a catch. Some of the robots struggled to stop after the race, crashed into padded barriers, and needed humans to come and pick them. And that's actually the more interesting part of this story, because today's robots are still far from the science fiction version we imagine. But they are getting better at seeing, understanding, moving, and interacting with the physical world. And that's where the concept of physical AI comes in. We have spent the last few years talking about AI that can write, code, analyze data, and generate images and videos. The next big step could be AI that can actually do things in the physical world. Industry consultants and investment analysts suggest that global robotics market could grow 25 times to 2.5 trillion in annual sales by 2035. That implies a roughly 35 to 40% annual growth rate from $100 billion in annual sales in 2025. And if that happens, it could create an entirely new technology value chain, from AI chips and sensors to motors, actuators, precision components, robotic software, and finally the robots themselves. So in this video, we'll understand this entire robotics and physical AI value chain, see which countries and companies are leading each part of it, and most importantly, where does India fit into this opportunity from an investor's perspective. The bigger investment opportunity could be in companies supplying the brains, eyes, muscles, and components that every robot needs. So this is part 1 of the video where we'll understand the value chain of robotics and where Indian companies fit into the entire ecosystem. In part 2, we'll deep dive into specific Indian companies that can benefit from robotics megatrend. Alright, let's get started. So before we start looking at companies, let's first understand what actually goes inside a physical AI robot. Because when we hear humanoid robots, we tend to think of it as one product. But in reality, it is a combination of several technologies working together. And the easiest way to understand this is to compare a robot with the human body. The first thing you need is a brain. That's the AI and computing layer. The robot needs to understand instruction, process information, and decide what action to take. This is where AI models, processors, and onboard computing comes in. But a brain is useless if you can't see or understand what is happening around you. So the robot needs eyes and sensors. This is the sensor layer. Cameras, lidar, that is light detection and ranging, radar, force sensors, tactile sensors, and encoders. They allow the robot to understand where objects are, how they are moving, and even how much force it is applying. Then comes the part that actually makes the robot move. It's muscles and joints. This is the motion layer that includes your motors, actuators, gears, reducers, bearing, and controller. If the AI decides pick up that bottle, this is the hardware that actually moves the robot's arm and fingers. And then you need the body itself. The actual frame, battery, wiring, cooling, and all the mechanical components that hold everything together. But there's one more layer that is becoming increasingly important with physical AI. That is software and training. A robot does not just need an AI model. It needs software that connects the model to the hardware. It needs simulation and digital twins to practice tasks, data to learn from real-world interaction, and systems that allow companies to manage thousands of robots once they are deployed. So if you simplify the entire value chain, think of it like this. You have AI and compute, then sensors, then motion and actuators, then power and structure, then robot, and of course, your software and application. Or in human term, your brain, eyes and sensors, muscles and joint, body, and of course, intelligence and skill. And all these layers have to work together. For example, imagine you tell a humanoid robot, pick up that box and put it on the conveyor. The AI understands what you said. The camera identifies the box. The sensors figure out its position and weight. Then the AI plans the movement. The controller sends instruction to the motor. The actuator moves the arm. The robot hand grips the box. And finally, the robot places it on the conveyor. That entire process from understanding to sensing to movement to execution is what makes physical AI so different from the traditional software AI. Physical AI has to perceive the real world, reason about it, and then act within it. And there is an important investment point here. Not every dollar spent on robotics will go to the company that makes the final robot. For example, McKinsey estimates that actuators alone could account for roughly 40 to 60% of a humanoid's bill of material, while your sensing, compute, and other structural components make up the rest of it. So the opportunity could be spread across the entire ecosystem. And now that we understand the value chain, let's see which countries are actually leading each layer and where India fits into this global robotics opportunity. Let's start with the brain of the robot, because this is where the biggest change from traditional robotics is happening. A traditional industrial robot is largely programmed to do a specific task. You tell it exactly what to do and it repeats that task thousands of times. Physical AI is trying to make robots much more flexible. Imagine telling a robot, go to the kitchen, find the red cup and bring it to me. The robot now has to understand your language, identify the cup, understand its surrounding, plan a path, avoid obstacle, and then physically pick up the cup. All of that requires AI model and computing power. And this is where US has a huge lead, particularly through NVIDIA. NVIDIA is building what is effectively an entire computing platform for physical AI. Hardware for training AI, computers for running AI inside the robot, and simulation software that allows robot to learn and practice in virtual environment. So think about NVIDIA as providing part of the brain and nervous system for the next generation of robot. But NVIDIA is not alone. AMD is also positioning its embedded AI processors specifically for robotics and autonomous machine. And then you have companies developing the actual AI model for robots. Companies like Figure, Fanuc, Skid AI, and others working on what are increasingly called vision language action model. So the first layer of our value chain is the brain, where US currently has the clearest advantage. But the brain alone is not enough. Robot needs to understand what is happening around it. And that's where the next layer, that is sensors, become critical. A physical AI robot can use multiple types of sensors. Cameras help it see object and understand its surrounding. LiDAR and radar helps it understand distance and movement. Encoders tell the robot exactly where its joints are positioned. And force and tactile sensors help it understand things like how hard it is gripping an object. And this is why your Japan, Germany, the US and China have built strong positions in industrial sensing and machine vision. Companies like your Keyence and Omron in Japan, Cognex in the US and SICK in Germany are examples of companies operating across your industrial vision and sensing. Now we come to what I think is one of the most interesting part of entire robotics value chain, the robot's muscle. The AI can decide, pick up this box. The camera can identify the box, but none of that matters unless the robot can actually move its arm, bend its finger and lift the box. That's the job of motion actuators, gears, reducers, bearing and controller. And humanoid robots make this particularly interesting because a human body has a huge number of joints. You have got shoulders, elbows, wrist, hips, knees, ankles and fingers. Every one of these movements require a compact and highly precise motion movement. This is where Japan has built an enormous technological advances over your several decades. Companies like your Harmonic Drive and Neptesco are major players in precision reducers and motion control component, while companies like your Nidec, Yasukawa and Fanuc have deep expertise in motors and industrial motion. China, meanwhile, is aggressively building its own supply chain, helped by its enormous manufacturing ecosystem. And this is where India gets interesting. India may not have a leading humanoid robot company today, but we are already having a strong ecosystem in precision machining, bearing, gears, motors, forging, casting and auto component. Companies like your Sona BLW, Schaeffler India, SKF India, Sansera Engineering and Craftsman Automation operate in parts of this broader precision engineering ecosystem. Now, I'm not saying these are robotic stocks. The investment thesis only becomes interesting if these companies actually start winning businesses from robotics, either directly or through global customers that supply the robotic industry. So what we will do is we'll discuss these Indian companies and their role in physical AI separately in second part of this video. Now, so far we have looked at the robot's brain, eyes and muscle. But there is one critical layer connecting all of them: the electronics, control system and software. Think of this as robot's nervous system. Just like our nervous system carries signals between brain and muscle, a robot needs controllers and electronics to translate AI decision into precise physical movement. A robot needs printed circuit board, control board, power management electronics, communication modules, sensor electronics, wiring and other electronic assemblies. An EMS company can manufacture these for the robotic OEM or for the companies supplying component to the robot. This is where your Indian EMS companies like your Sirma SGS, Keynes Technology, Dixon, Sign DLM, Avalon and one unlisted company, Tata Electronics, could potentially participate. And finally, there is system integration. A robot could have an NVIDIA processor, cameras from one company, motion from another, actuators from third company and a battery from somewhere else. But someone has to bring all these pieces together and make them work as one reliable system. This is where your engineering and system integration companies can play an important role. And this is potentially an interesting area for India because we already have a large engineering and embedded software ecosystem. Companies like your Tata Elxsi, KPIT, Cyient, L&T Technology and Tata Technology have capabilities across embedded system, automotive software, electronics and industrial engineering. But I would be careful about calling all of them physical AI play. The real investment opportunity will be in companies that can demonstrate actual robotics exposure through customers, orders, products or meaningful revenue. Finally, you need to pull all of this together. That's the next layer, the actual robot and companies building it. In the US, you have companies like Tesla with their Optimus, Figure and Agility Robotics trying to build general purpose humanoid. The idea is that one robot should eventually be capable of doing many different physical tasks rather than just being programmed for doing just one job. China, meanwhile, is moving extremely aggressive. Companies like Unitree, Ubitech, Egibot and Xpeng Robotics are developing humanoids and trying to bring down the cost through China's huge manufacturing ecosystem. And something remarkable happened just this month. Unitree actually became a public listed company in Shanghai. And guess what? Its stock price surged more than 5-fold on its debut itself, giving it a valuation of roughly $50 billion. That's remarkable considering commercial humanoid robotics is still in a very early stage. And this tells us something important about how seriously the market is beginning to take this technology. But we should also keep some perspective. Most humanoid robots today are still far from being general purpose worker. They can perform impressive demonstration, but getting a robot to reliably handle thousands of unpredictable real-world situations is a much harder problem. Even Unitree's CEO recently suggested that a true breakthrough could still be several years away. So if we step back, the robotic and physical AI opportunity is much bigger than just humanoid robot. You have the brain, which is AI and compute, the eyes, that is sensor, the muscles, that is motors and actuators and nervous system, electronics and software, and finally the robot itself. And what makes this interesting from an investment perspective is that you don't necessarily need to own the company building the final product. There are multiple layers of ecosystem that could potentially benefit as robotic adoption increases. But now comes the question that is probably most relevant for us as Indian investor. Where does India actually fit into this value chain? So in part 2, we'll map Indian companies across this entire value chain, look at what capabilities they actually have, what robotic opportunities they are targeting, and how meaningful this opportunity could become in their business. But I'll also discuss the other side of the story, the key risk. Because this is very exciting theme, but there's a big difference between a company talking about robotics and actually generating meaningful revenue from it. And when a theme becomes this exciting, valuation itself can become a major risk. So that's what we'll discuss in part 2. If you have any doubt, let me know in the comments. And if you find this video useful, do share it within your circle. I'll see you next video. Till then, take care.